What is up, everybody? Thank you so much for tuning into another episode of the Anti-Gravity Group podcast. My name is Braden Carlson.
My name is Taylor.
My name is Shane, or as you might know me, Postart.
And if you aren't familiar with our today's guest by name, you're almost certainly familiar with his iconic onboard footage, which kind of shows his Kevlar shot cord weightlessly drifting at the edge of space with a breathtaking view of Earth in the background on board his two-stage rocket called Mesos, which I learned is pronounced that way from the RocketryShow.com podcast, so shout out to those guys. But everybody, please welcome Kip Daugirdas to our show.
Wow, that was good with the pronunciation. That was awesome.
Thank you. Yes, and we just finished talking about that pre-roll. I was like, I want to say your last name right. But yeah, thanks for having us, man. Well, thanks for us having you.
Yeah.
You know.
Thanks for having me. Yeah. I'm totally down to talk shop for an hour and a half, or whatever.
But yeah, so I guess unless anybody else wants to ask something first, we can dive straight into this. What I've got anyway.
Yeah, start it out. Go for it.
Yeah.
All right. So this is what we ask pretty much everybody that comes on the podcast, but where did it all start? How did you get into rocketry in the first place?
Oh man, I think I've always been into rockets, even like even when I was super young. My mom was actually like totally against it. She thought they were fireworks. But I'm kind of older. I'm guessing I'm older than you guys. I'm 38. So when I was like in 7th grade, the movie October Sky came out, and I think I went to the library to go get books on rockets, and the only book that they had that was like applicable was like G. Harry Stein's Rocketry Handbook.
Oh, wow.
And so like I picked that up and bought some Estes kits and just started building. And so that's how I started. And over the course of like a couple years, I found like High Power Rocketry magazine at a hobby shop. I met Tim Lear before he was even Wild Man. I mean, Tim was working at a hobby shop not far from where I lived, and he was like, "Hey, go up to Tripoli, Wisconsin, and come to the launch at Bong." Bong was 45 minutes or an hour from my house. So
Al's
I went up
hobby
there
shop.
with my dad, and Al's hobby shop. Yeah. Like way back.
Yep.
So then I don't know. I just started getting into high power. I built all my dad's certification rockets. There was no Tripoli mentorship program at the time then. So, I'd build the rockets. My dad would say, "Yeah, I built it." People still figured out that I was
on the tail end of that.
Just started building bigger and bigger stuff. But like back then, living in Illinois, there's lots of trees, there's cornfields and stuff like that. So I built just kind of your quintessential high power stuff, big rockets that didn't go super high. And the rest was kind of history. Went to college, and that's where I started wanting to get into the high performance type stuff. But still, being in college, it was, mid 2000s, and tracking still was terrible back then. Like GPS was just starting to kind of come out on the scene, and it was really bad and really flaky. So really the best that we had was an RF, transmitter, which, people still fly today, but mostly fly as like a backup, because GPS has gotten a lot better.
Absolutely. Yeah, we so Taylor and I were both teenage rocketeers. We were behind folks like you and Art Hogue and Steve Heller and Woody and everything.
Yeah.
But not too far behind. And like I was saying, I had a bit of a unique use case in that my dad was actually into rocketry, so he still flies and everything. So yeah, we're all old school around here. We like just came out of our boomer rage of not wanting to transition to GPS, and, we're way behind on the times. We love our REF beeper.
We're on board now, though. We just had a good run with it, so
yeah.
Nice.
But yeah, so I guess
Nice.
further into your, we'll say, rocketry career here, was there sort of like a defining project or moment you remember that made you go like, oh, I want to do high altitude stuff? Because starting out at Bong, I flew there for the first time last year. I was like, nothing about this place makes me want to fly high.
No, you want definitely want to keep it like at 5,000 feet or below, low and slow. I don't know. I mean, by the time I got to college, I had like flown a 2-stage rocket. It was like a 7.5 to 6-inch. It was a monster. It was 17 feet tall, weighed like 130 pounds. And I flew that at a couple LDRSs. And it didn't go particularly high, like 15,000 feet. The upper stage got up to. And I kind of felt like I had maxed out what I wanted to do in terms of like the traditional high power stuff. So I kind of started getting into the minimum diameter stuff. And then in 2007, I went to Balls with the University of Michigan with the Rocket Club. And it was pretty much, I built the rocket, like the whole rocket. And, we had like 5 or 6 guys come with to just go hang out at Balls. And that was back when like Balls was the Wild West. People showed up with cannons. There was no such, safe distances were like more suggestion than the rule.
Right.
And so we flew this, this noodle of a rocket. It was 3 stages. And I think we got like the most cartwheels in one event. I mean, it was a disaster. Then
there's video of that.
College ended. And like everybody, you went and got a job. I got a job in Boston. I lived in a little apartment, and I didn't build rockets for like 5 years. So like from 2008 to 2013, I didn't fly anything. I just paid my dues, and that was kind of my involvement. And in 2012, things started to change. Like I heard about the Carmack Prize. Derek DeVille flew that Quake rocket. 120,000 feet. And then, Jim Jarvis came on the scene with like a 2-stage that, started to fly on like much smaller motors.
Yeah.
And then the Arliss rocket from Aeropack, the 100K Arliss rocket was even smaller and made it to 100,000 feet. And at that point, like I had moved to Utah and, rent was cheaper. I was renting a house, and I had some more disposable income in a small garage. And I'm like, I kind of want to get back into rockets. So, had my parents ship out like, all my minimum diameter stuff to Utah, and I gave it a go in 2013. Thinking that, how hard can this be? Once again, that rocket also did not work and did cartwheels. It came back a couple years later with something a lot better, and just kind of kept trying and kind of building out like my tools and doing things more professionally in terms of building the rockets. But I started with the commercial stuff, like flying commercial motors, and hit like 150,000 feet with that stuff. And all along, I knew that if I wanted to go higher, like I would need to eventually get into EX type stuff. So
that is crazy too. 150,000 on commercial motors. I remember when Jim. So I used to just bother the crap out of people as a teenager. Like Vern Knowles and Jim Jarvis. I've said this a lot on this show and on my channel. The fact that they still like talk to me is crazy because I used to just email them constantly. But I remember when Jim did that first 4-carb yen flight, the N5800 to N1100, like you said, it was just 100,000 feet going from Derek's 8-inch Q to suddenly 2 commercial motors made it to 6 figures was like enlightening. I was like, how is that even possible from my perspective? So, but what was your flight?
It opened it up to like everyday people.
Right.
It just opened it up, and so that was eye opening, and so definitely wanted to get into it. So that was my start, I guess, or my restart into high power.
Right.
and I hope to not take any breaks. I hope to kind of stay at like a constant, slow and steady pace with the projects from here on out.
Yeah, that's fair. It's way easy
So-
to burn out if you just like really get too lost in the sauce.
Yes.
So-
absolutely.
In sort of the timeline, then, I guess from that point to 293,000 feet, what would you consider is your worst overall failure throughout all of that?
Oh man. I would say that the most defining one was probably in 2019. At the time, like Charlie Savoy contacted me, and Aerotech was working on the 05280. And he was like, we should do a project like together, like an Aerotech, Kip project. And I was like, yeah, let's do it for sure. He's like, we'll supply the motors, you build the rocket. I was like, okay, deal. And
It's a good deal.
I built a beautiful rocket. I mean, it had like the Aerotech logo on it, and it was all like carbon fiber underneath. So like the stencil was like Aerotech, but it was like black carbon underneath. It was to the nines.
That's awesome.
The whole thing was like beautifully Cerakoted and glossy and gorgeous. And that flight was a disaster. It put me on the naughty list at balls. It wasn't good. The motor burned through like a second into the flight. So, and on top of that, like I was having all sorts of trouble with my tracking. I had like a new Beeline GPS that was supposedly unlocked to above, 50 kilometers or something like that.
Right.
And that thing just wasn't syncing well with like the Beeline that was on board. So my like tracking was messed up. One of my flight computers went out of cal at the launch pad and just would not turn on. So I was just like at the pad, I'm like, I'm running on one flight computer in the upper stage. Like, screw this. Like, and
That's bold.
so it was bad. And so the rocket takes off. It burns through almost instantly. Like, luckily it left the launch pad before it burned through. Burned through on the forward end. So it's looking, like the Challenger disaster,
Right.
And the upper stage separates, and I'm like, okay, the booster's toast, but the upper stage will just coast up and pop its chutes and come back. Like, I've had no lights before, no big deal. It didn't. It lit, and it lit like a cruise missile, and it like just headed to the southeast, like it was running late for coffee in Winnemucca or something.
What motor was it? 685?
So it was a 685. Yeah. And then like everybody was like, what were your staging settings and all this stuff? And it was a whole disaster. And for like the first time, like even when I went to BlackRock in college in 2007, like the cartwheeling rocket, the 3-stager, we recovered all of it. But this one, I like lost everything, all my avionics, all the cameras, like on both stages, never found the second stage. It was gone. And so that was like pretty defining, pretty humbling.
Yeah, that's rough.
I was like, unequivocally pissed that the motors didn't, the motor didn't work, but like,
right.
I mean, that was just like the tip of the iceberg. Like the rest of the rocket was clearly screwed. So it kind of forced a clean slate solution. And so that's
Right.
that is how Mesos kind of started. I got back from balls, and like 2 weeks later, I was like, you know what? I'd been kind of like gathering mixing supplies. I'd bought chems. I bought like a Hobart mixer. I hadn't really used it. I'd kind of messed around in the KitchenAid a little bit. But, after that launch, I just decided, I'm going to give this like a serious college try and try to do it right. And just kind of got started late in 2019 with kind of figuring out propellant. I figured just like, let's see how far we can get. And and if we can make these motors, then we'll build the rocket, and so kind of start from there. Yeah, that was the defining moment.
That's crazy. Those
So
early
how long
05280s were
How long?
really problematic.
Yeah, they were. And I think they've redesigned it. I think it's an 05500 now, and I think they work great. So, yeah.
What were you saying, Taylor?
How long was it from when you started that the adventure of getting into propellant, mixing your own propellant, to the next? I guess would it be the Mesos flight?
Yeah. So that was in like October of 2019, and then I flew Mesos 3 years later. So it was decently quick. The first year, 2020, was pretty much just like, I didn't even fly. I wanted to fly like a little test rocket with my own motors, to like be my first hurrah. Like, yeah, I flew a rocket on my own propellant. That didn't even happen in 2020. Like, I was still having trouble getting 54 millimeter motors, like a K or even like a baby L to work properly. In 21, I started to, figure it out. Like, I started, testing the motors. They started working really well, started flying them after testing them on the ground. And then, the pace like really picked up in 21. Then 22 was essentially building Mesos. And the whole time I was kind of designing it at the same time, so, the test flights and the motor tests definitely helped in like framing what the rocket was going to be. So,
well, I'm glad you brought up design. That brings us to our next question.
Yeah.
Taylor and I both recently did 3-inch minimum diameter projects, and we were very open with the fact that we saw your rocket, saw the fin shape, and just blatantly stole it, because we noticed it's kind of Arcus fin shaped, and we started playing with it in RAS Aero, and for some reason the numbers just kept getting bigger. So we were like, oh, this guy's onto something. So how exactly did you land on that fin shape?
Oh, man. I think the only reason I picked like a clip delta is mainly, I would say, like, a lot of people like to do high performance rockets with like the swept-back fins, and like undoubtedly aerodynamically, like those are the best fins to use. The issue that I have two issues with it. The first being very simple. Like, if your shock cord kind of gets wrapped around behind that fin, like it's over. It's not unwrapping itself from that fin.
Right.
So that was kind of a disqualifier right there, just because I didn't want to like run into like the recovery issues with those types of fins that can present them. I'm not saying it's going to happen every time, but it can. And so like my whole job in that project is just to mitigate risk. So I went with, the clip delta, the Arcus shape.
Yeah.
And like the only thing I do is like I cant the trailing edge in a little bit so that if the shock cord does wrap around it, it just slips right off.
Interesting.
And then honestly, to tell you the truth, like I just size them so that I keep my, the stability above 2 calibers during like the fastest portion of the flight. That's really kind of how I come up with the fin shape. And I try not to skimp too much on like the tip cord. So like the length of the tip of the fin, because that's really what's cutting into the air the most. So it's good to have a decent amount of tip cord, but yeah, I don't think there's anything special with the design of those fins. So
yeah, that's interesting to hear.
That's sort of when you had your highest flight, I guess that was the last, or not the last, the one before the last flight. I don't know how did this whatever, but we were just like, wow, that is basically Arcus fins. And we were, it seems like that shouldn't work. And so it's just pretty inspiring to see, a normal guy building a pretty normal rocket and getting that kind of performance out of it.
It's a pretty normal
Sorry.
rocket. It does not have a whole lot going on. That's too secret saucy in terms of its design. It's pretty
Yeah.
average.
If you're curious
I
about
think the
think
one
it's
thing
awesome.
that makes that rocket above average is like it's just the whole thing works, right? So like all the components of it just kind of come
Yeah.
together and they jive and they work. Like that's essentially the cool thing about it. But like there's no one thing about that rocket that, I think the motors are, above average. I think the design is, pretty compact, but it's nothing that wild, So
Yeah, I'd say another thing that puts it above average is the fact that it's flown 3 times and you still have it, all of it.
I still have it. Yeah, like this part behind me, I think its cumulative like altitude is 600,000 feet so far.
Wow.
That's crazy.
So not bad.
I
Hope to get to millions.
Vern was so I'm from Idaho. So before I moved to where I'm at now in California, I was going to a couple Tripoli Idaho meetings, and right after your flight to 293,000 feet, he was like ecstatic that the Kate went that high, and he had all this cool data, and that was interesting to see too, because that was the first time it had like ever needed to cross my mind that a rocket doesn't need to be pointed straight up and vertical once there's no more wind resistance. That animation of the rocket just tumbling, I was like, oh my god, it's still going Mach 2 and it's just kind of doing cartwheels.
Yeah, it's bananas.
Crazy. This is not something I would have ever thought about before, but yeah. So when I saw that, I was like, are you serious? This is crazy. But yeah. And you wouldn't really notice it from the footage either, but if you weren't thinking about it anyway. But
and then it's pure luck that spinning slow enough to capture good enough footage. That first flight was just, I don't know, everything aligned. It was perfect. So,
yeah, it really came to. How high did it simulate to?
270,000 feet. But I was really just hoping, gosh, if I got above 150, I would have been happy. Above 200, I would have been, ecstatic. I never thought that it would, go the full plus sum.
See, I was always curious about that, because I feel like I read somewhere that somebody said you were expecting 250,000. I was like, it is crazy to just like accidentally find another 93,000 feet or 43,000 feet in altitude over 250. But yeah.
Yeah, it's nuts. I mean, like, even while the flight was happening, like, I was like, no way that I think like something, it's getting erroneous data. Like, we're not gonna say anything on social media until
right.
we download the footage or like look at the videos and stuff and see what actually happened. But lo and behold, it actually did it. So yeah,
that's crazy. But it's not the first time I guess we've seen a rocket. So Taylor and I were at the Evolution Space flight that went past the Kármán line, and that was quite a bit over the sims, if I recall, as well. So it's something, you can only rely on simulation so much, but when there's like 5 people on this planet flying that high, there's not a lot of data to go off of to kind of optimize the sim program.
Yeah, I mean, I think like, so all I had to do is like uncheck one box in RAS Aero. I think it was I had assumed that the rocket's finish was going to be like this rough paint finish, which increased the drag in the simulation, and it turned out that the rocket I didn't really get that rough a paint until it got high enough where it didn't really matter. So really just on checking that, actually it came super close. It came within a few thousand feet. So
interesting. Yeah, I guess I didn't think about that either. If you have a rough paint surface but there's no wind resistance, it's not going to do anything. Wow, high altitude stuff's
and then
crazy.
Like these motors also, like I tried to do my best with testing them on the ground and testing them with load cells and pressure transducers so that I actually knew the performance of them, so that sim would be decent. I mean, especially for the booster, because the booster motor essentially choreographs the entire flight in terms of like how long are you going to pick to gap stage for that delay, which is super important because the longer you gap stage, it's the higher you're going to go. So getting that data was important.
Right. Yeah, that's the whole stage. The first time I saw a Jim Jarvis flight in person, like the time spent between dropping the booster and lighting this sustainer, I was like, oh my God, that is insane looking. But
yeah.
Well, Shane, you've got a couple of questions written in here. Fire them off.
Yeah. So I mean, obviously you've had a couple or possibly more that we haven't seen high altitude flights. What, in your opinion, has been the most difficult part of each one?
Recreating my own success. I don't know. The most difficult part of each one. I haven't had that many like high altitude flights. I think I've crossed 100,000 feet 4 times and 200K twice. So it's not that many times. So I don't think I have a very good sample to honestly tell you that I 100% know what I'm doing. Because every time I go and fly these, I learn something new. And like my assumptions often get debunked. So I think the hardest part is just with the big flights, they're just a lot of work. It's a lot of man hours. I think even with like Mesos, like recovering the whole thing, but getting it back up, flight ready and ready to go, given the rocket's fully reusable, is still like 80 hours worth of work. And trying to find 80 hours, part-time on the weekends, and like rockets aren't the only thing I want to do, I want to hang out with friends and, go to dinner, go get drinks and stuff, go exercise, whatever. It can be tough. So last year flying twice was not that bad, but I definitely wouldn't want to go try to do one of these flights more than twice a year. It kind of ate up all my time that I had available to do this. So
yeah,
I actually we almost reached out to you. It's worth noting we've never talked before this podcast, but we live about an hour and 45 minutes from FAR. So we almost reached out to be like, hey, can we please come see this flight? And we ended up actually being out of town the weekend that the last flight. But
yeah.
So when you come back out here, let us know. We know we've got Matt Daly, but we've got some camera stuff too. We can try and keep up with Matt.
Oh, Matt's awesome. I love Matt. Matt's the best. That's the best.
The photo he got from the tower with the sound trigger at FAR is the craziest thing. That he's like, I just put it up on the sound trigger and hope, and it's just like perfectly framed, beautiful picture. I was like, what? Okay, cool.
Yeah.
There are a lot of talented people who show up to and take photos there. I mean, all those young kids are crazy talented photographers. I have more photos than I know what to do with. So I'm very grateful.
Yeah, and then the other one that I had put in here, what's the end goal with all of it? Or if there really isn't one in sight at the moment, what is the driving factor behind all of it?
The end goal. I don't know. Maybe I'm close to the end. I don't know. With Mesos, I think I can get more performance out of that rocket, and so my goal now is to see if I can do that. I think I can get another 50, maybe 100,000 feet out of that rocket without having to, increase the impulse level of any of the motors. So I'm going to try to max that out and kind of see where I go. The flights 2 and 3, I haven't posted any videos. I posted some pictures and like a couple updates on those flights. Flight 2 had really bad pitch roll coupling. It only did like 94,000 feet. So it was a pretty lame result. Got the rocket back. Like flight 3 came back. I thought I fixed everything and was super excited, and it did do a lot better. It got up to 233,000 feet, but like it again ran into some pitch roll coupling issues, despite my best efforts. So I'm kind of tackling like 2 problems right now. So one is the pitch roll coupling, and then the second thing is trying to increase the performance of the rocket. I'm hoping to solve the pitch roll issue and the performance thing kind of with, I'm hoping, a golden bullet, which is just a new upper stage motor. The upper stage right now is a moon burner, and so it's got that off-center mass. So if you have any kind of spin in that rocket, it can start, really inducing pitch roll because you have that off-center mass. Even if your spin rate's pretty low, and the rocket was only spinning like 2.5 times per second at the max rate, which it, for all intents and purposes for a rocket is, even a high performance one, is not that high. And I wouldn't expect it to behave like mine did. But when you throw in that off-center mass of, the propellant burning from one side of the motor to the other, kind of all hell can break loose. Right. So I want to do an end burner. I don't know if I can. It's a really difficult motor to build and design. I've just started. This past Sunday, I tested 3 end burners. They were small, 54s. They're like 6 inches long in terms of their propellant length. So there's not, they're a long way off from a flight worthy motor. Right. And I just know based on the results from Sunday, it's like, yeah, this is gonna be a challenge. But if it works, right, gets rid of that off-center mass thing, maybe I can also, it alleviates this pitch roll thing that I've been running into the last couple flights. Even a little bit flight 1, but it was far less. It didn't impact the performance. So I'm hoping that it fixes it. But if not, then maybe I need to look at like spin stabilization and actually purposely spinning the rocket, and then, designing like a D-spin, like kind of turning it into, a real-ish sounding rocket kind of deal.
Right.
So I think I have like enough stuff on my plate to play with, probably for like the next 5 years. So yeah. Or maybe indefinitely. I don't know. Like, I
was gonna say, man, if you get that all knocked out in 5 years, like that's a crazy amount of time to just die.
Yeah, I'm not saying I'm going to be back anytime soon. It'll be definitely a wait and see how things progress. But I hope it's not 5 years, but maybe 2 or something like that. We'll see.
End burner really is kind of an optimized sustainer motor. Taylor and I, on a much smaller scale, have a project for balls this year that uses an end burner sustainer. It's a commercial motor, but the altitude just simulation wise is crazy.
They're totally badass. And you brought up the Arcus, right? I mean, that is hands down like the coolest rocket ever, because literally you could fit it in a sedan and not have to break it down, and it could fly by itself to 200,000 feet. And being like 4.5 inches in diameter, and like I think it's only like 8 feet tall. The real rocket. To be able to hit those altitudes, and plus have like a massive payload capacity, right? This isn't some low-key dart, right? This thing could carry 8 to 12 pounds of like usable payload up to 200,000 feet, I mean, you could fill it with all sorts of GoPros.
Yeah, exactly. Yeah.
So
we're big Arcus fans around here. We kind of went the opposite way and did it a little dumber. We built a 2 times upscale of the full scale because we thought it would be funny to upscale a full scale rocket. So we have a 9-inch Arcus, which is questionable, but we have one.
I saw something about that project. Yes. Yeah. That's cool. That's awesome.
That was one of those say it out loud and it's dumb enough that everybody's like, but what if actually? And then, it's real now. So
and I know you guys are into clusters. So and air starts and stuff, and I think that's really cool. I haven't done a proper air start rocket, I think, ever, and that's up there on that list. So I think when I'm like an old timer, I think I'm going to get back to my roots of just building like big cardboard rockets that, you know, are fun to watch.
Oh yeah. So I did Oh, go ahead, Taylor.
I was slowly getting close to the rabbit hole of going all in on high performance, and then met Braden, and we decided to build big, dumb, fun rockets that like we enjoyed when we were kids. So
at some point you're having more fun than me. So
I will confirm it is in fact a blast, but I still like the high performance stuff too. But it is a rabbit hole to fall down.
Yeah, right. Yeah, it's a rabbit hole, and it can definitely be frustrating.
And that's the thing too, is it can be wildly expensive, like really quickly, if you're trying to obtain these altitudes and things start going wrong. Like motor hardware gets, even if you're making your own, way pricier when you're buying 4-inch aluminum or 4.5-inch or whatever.
Yeah. I mean, like the whole thing, like radius squared, right? It just like it's an exponential increase in cost the bigger your rocket diameter as it grows. It just the time to machine everything and like the raw material cost, and then you start filling up like 4.5, 5, 6-inch pipes with propellant, and it's just like you start going through buckets at AP real fast, alarmingly fast. So I definitely try to keep them as small as I can, in terms of my approach.
Spent crying at the destruction sites is exponentially affected as well.
Yeah, and like you see people go to balls and stuff, and they'll bring like a 6-inch, 8-inch booster to like a 4-inch upper stage, and often it doesn't work kind of early on in the flight, and like you never hear from them again. Like they just disappear. Right. Like it was enough to it was enough of a hit to them that they don't even want to come back and and do the hobby anymore. They go do something else, So to some degree I can understand. I'm like, I feel that.
Yeah. But I mean I would say that's kind of the same reason the Arc is as cool is a good point to why your rocket is cool too, though, because like you said, you could fit it in a little hatchback or sedan and just show up and fly at 200,000 feet.
Oh, legit. Like the launch pad trailer, literally, I used to own like a old Subaru Impreza, and I would tow the launch pad behind it. And so this awesome. Rocket totally can fit in a hatchback and fly over 200,000 feet. Yeah.
Taylor has a WRX. It's now a rally car, but his rockets used to be decided lengthwise by whether or not they could fit in the back seat of his WRX.
100%.
But all right, so we've got sorry, go ahead, Taylor.
No, I was just agreeing with
Oh, I see.
Rockets that fit in Subarus.
So we have a mailbag segment here where we throw questions to Patreon supporters over at patreon.com/rocketvlogs. And so we got a few questions if you're interested in fielding them.
Happy to.
So David Bratz, I hope I pronounced your name right. We just went through this whole thing, the last name pronunciation stuff. He asks, what products would you like to see that would drastically lower the cost of barrier to entry for 100,000 foot flights?
Yeah. What would be the biggest barrier to entry? That one's a really tough one to answer. Mainly because it's just the sheer volume of stuff you need to wind up buying that isn't the rocket to build these projects. But I would say, honestly, I probably the motors, I guess. But their price has probably gone up considerably. So some cheaper reloads. But I mean that's a hard one to tell because if you're gonna go fly one of these like 4-3s to 100,000 feet, like it has to be a pretty high performance like composite rocket and. learning how to do the composites and buying like a vacuum bagging setup and an oven to post cure this stuff, because you're flying pretty fast, so it's probably a good idea to run like some higher temp stuff. It just it's really, honestly, it's the time to learn the techniques and really just the stuff you need to learn is the barrier to entry. It's the time that you need to put in to really figure it out, I think, is the biggest barrier to entry. Not so much the money side of things. It is expensive, undoubtedly, but like, honestly, you're never going to get it on the first try. I don't know anybody who's gotten, said, oh, I'm going to go do a 100,000-foot flight, never done one before, and just nails it on the first go. Like, I don't know anybody, not Jim Jarvis, not me,
Right.
not anybody. So I think it's mostly, time and your perseverance is going to be the real barrier to entry.
Yeah, that was an interesting question to me, because I was like, it would have to be that like the motors are so specifically optimized for the flight that there's not really an easy off-the-shelf solution across the board for that to happen. But
yeah, and the manufacturers need to make their money,
right.
So
he continues and asks, can you walk us through your game plan for making an end burner, if that's still in the books, and what are you using for liners and burn accelerants? You're free to not share any of this information if you're keeping it close to the
I
chest.
can share. It's fine. I can share a little bit. So what I'm doing is I want to do so the burn rate that I need to hit is essentially around 1.5 inches per second. Kind of shooting for like 1.4 to 1.6. And that essentially translates to around a 20-second burn for the propellant length that I have, which is 32 inches. I don't know any propellant that burns at 1.6 inches per second. I mean, Warp 9, not even close.
Right.
So basically what I have to figure out is can I get a propellant up to 1.6 inches per second? I think the baseline propellant, I'll never get there. So ultimately I have to go down some other path for the end burner. And a lot of people know with the Arcus, it actually used silver wires that are cast into the propellant, like full length silver wires through the entire propellant grain, to augment the burn rate. And for them, they didn't use HTPV for their binder. They used PVC. They were able to, with the wires, go from like a 0.4 inches per second burn rate with the baseline propellant up to around 1.6, 1.8 or something like that for the Arcus. So they could get that like 30-second burn. I think the Super Arcus had like a 40-second burn. So I'm trying wires and trying to figure out how many I need. What diameter wires do I need? Do they even work? Are there any kind of special coatings you can put on the wires to further push up that burn rate? So there's just like, a spider's web worth of like options to try. And it's just starting to kind of chip away at them and kind of start connecting the dots and figuring out the bigger picture. So that's really my approach. I think it's just going to be a lot of testing. And I'm starting at like back at 54s, mainly because it's just, it's cheap and I don't have to mix big batches of propellant or anything like that. And if I take, motor fails, I had one fail on Sunday, spit the throat. It's not a big deal. It's like, yeah, whatever. Right. So it's like, I'm losing, lost 400 grams of propellant and like tiny aluminum tube. It's not a big deal. Right. So that's the approach. And if the 54s show promise, with any one of those options, then, I'll step it up to a 3-inch and kind of just keep going and just really just make my decisions based off actual results. So
right.
The problem is it's just like incredibly empirical. Like you can't go and put this in a simulation program, can't read about it. I've read everything I can, and there's just not a ton of information about it.
Right.
So you just kind of have to go out and do it, and it's just a lot of testing. It's like a ton of testing. So
like you said, that's
the plan.
One of the things that makes the Arcus so sick is just how crazy it is on pretty much every level. His final question is, after your flight to only 90,000 feet, what did you do to prevent pitch roll coupling going forward?
So I found a few issues with flight 2. I've been like working literally for 6 months on one stupid YouTube video to cover it all. And I'm just like so piss poor slow at editing that I just have not finished. You know, it will probably be like 3 years after the flight that I actually dropped this video. But anyways, found a few issues. The perpendicularity of the aft end of the upper stage case was out by like 20 thousandths of an inch. The case is actually like the shape of a banana. Just really disappointing to find out post-flight. You know, the casing doesn't receive any machining on the OD or anything like that. It just comes, you know, as extruded stock. And aluminum extrusions vary so much, even in one length, like one stick of like 20-foot stick of, you know, 3-inch tubing, it can be bent at one end and perfect at the other. So that was an issue. The second thing was the fins on the Mesos Flight 1 got cooked pretty good on the leading edge. And I didn't want to have to go through and have to like recoat the leading edges every flight with like high temp epoxy or ablative or something like that. Mm-hmm. So I wrapped stainless steel sheet metal on there. And you would think, oh, this is like, that's easy. Like it's a single bend with sheet metal, you know? And it turns out to be like far more nuanced than that. Just getting like a perfect bend and like that perfect radius on the leading edge where it's not like biased to any one side is actually incredibly difficult to do without like, you know, like tool and die, you know, tooling. Mm-hmm. And so I think on that flight too, I had, I kind of had crappy leading edge caps, stainless caps, and that induced a pretty good spin rate from the get-go. So I fixed that, or tried to fix it as best I could. And then just try to pay attention to when I tack the fins on. And like, honestly, like the methods I use to tack the fins on are pretty, you know, Home Depot. They're in terms of their solution, right? So it's, you know, I literally go find like two of the straightest, you know, L channel, like aluminum channels at Home Depot. You know, I just go through the full rack. And I think there's like 5 Home Depots in Salt Lake City. And I went to every single one until I found the 2 straightest aluminum channels to mount the fins with. You know? I mean,
that's awesome.
Some of the stuff I do, it's kind of ridiculous. So those were the steps I took, and I made sure that the case wasn't bent, you know, on the third flight. So yeah, that helped.
Yeah, that's crazy. I would have never thought, if someone asked me why I thought that rocket did that, I would have never landed on. Maybe the case wasn't nice and straight, but that actually fed really nicely into one of our other questions, which was asking about any special treatment you do to the leading edge of fins. But he also asked what were some of the other challenges with, in general, keeping the rocket as close to 0 degrees off vertical as possible.
Yeah. So with the fins, flight 1, I used Cotronics on the leading edge, and then I put like the barbecue paint for the ablative. And for the other flights, I did the stainless caps. You know, neither the barbecue paint, the Cotronics, or the stainless caps are my idea. They're all things that other people have done before me, that I just kind of adopted. But in order to keep the rockets flying vertical, I think the most important thing that almost I never see on like the Rocketry Discord or people talking about on the Rocketry forum is the launch pad. Like nobody talks about it. They're like, yeah, we'll just use the launch pad at FAR. And I know FAR got some new pads that are actually pretty nice, that Eric was working on when I was there last time. But some of those pads have had a few Katos on them. And if you close one eye and look down the rail, you'll notice it's rather squirrely. It looks like a fun road to drive on in your car instead of, a boring straight interstate, So, ensuring that like the pad is stiff, that the rail is long and that the rail is not warped in any way, that everything is kind of straight and true. Spend a lot of time leveling the pad, staking down the guy wires, making sure that everything on that pad, so when that motor lights, it stays pointed vertical and sends the rocket going up. That's probably the biggest thing, I think. And then the second thing I kind of touched on earlier was just knowing your rocket really well, or knowing your rocket motors really well. Like if you know the performance of that booster motor and your sim's really good and you know the weight of your rocket and you know the thickness of your fins and all that, you can really simulate the flight well, so you know when to touch off that upper stage. Because if you wait too long, it's going to arc over, right? And if you don't wait long enough, then you're kind of leaving some performance on the table that you could have had if altitude's your goal, So I think those are kind of the two things.
Cool. That came from Nick Pearl, by the way. He has one more question: is what do you know about, what do you know from doing carbon layups now that you didn't and maybe wish you knew when you started?
I was a pretty good pro at like just hand layups and not doing any kind of vacuum bagging before I got into the because I built the big flying barn rockets, where it's like
right.
an entire pallet of Home Depot wood on board. So I got decent at layups, just doing just standard wet layups, and then kind of getting into vacuum bagging was easy. I just watched YouTube videos. There's some like good composites channels. Easy Composites is one that kind of comes to mind. That they do great tutorials on all sorts of layups and doing molds and everything. Jim Jarvis wrote some really good papers.
Yeah.
So yeah, I think I read those, and honestly, I didn't find the composites to be that hard. Just had to do it. I think finishing was the hardest thing, like filling in the weave after you're done with your layup, like that has kind of been the challenge. So, and that's where, using lots of layers of peel ply helps. So when you finish your layup, put a layer of peel ply on there and just then tear it off, and then just put another layer of peel ply on there after that one is dried, right? And just kind of load up the fin that way before, and that'll give you a nice finish in the end. Yeah.
That's good info. Yeah, I mean, when I was a teenager, I probably could have word for word recited Jarvis's Rocketry Planet article on doing carbon, because like it was my Bible as a teenager.
It's still applicable today. Yeah.
Oh yeah.
Yeah, 100%.
Neutronium asks, for someone who has some experience with high-performance single-stage rockets, what should you look out for when getting into multi-stage high-performance rockets?
Yeah, I mean, multi-stage is not twice as hard. I'd say it's at least like 4 times as hard as the single stage. I think the biggest thing is like, look, just keep trying to build a rocket as short and squat as possible. Don't do what I did in 2007 and build a spaghetti noodle rocket, right? That's like super noodly and just like doesn't want to like, yeah. You want like a short, rock solid, a rocket that can handle, a high speed flight, and plus just having another rocket on top of it. So there's that, just get good at CAD, because you can honestly get a lot of benefits from playing Tetris with the components and the electronics. you might find some really cool solutions where you can fit stuff where you didn't think you could, which helps you kind of build a shorter rocket. I think the other thing is just like the recovery system. You know, I think I wouldn't like get into the high performance two stagers if you're still like driving your single stage high performance rockets into the ground. You know, like you still got some work to do there. But if you're recovering them and you're having good flights with the single stage stuff, there's like no reason why you can't, stack another one on top of it. Yeah, it's not particularly that hard. I don't think. You do have stuff where like the sim matters a lot more on a two-stage rocket. A single stage is like, who cares? You just light the motor and the altimeter does everything it needs to do, right? Or the GPX. But on, there's some like you have to think about, and there's some planning to do with the two-stage, because you got to figure out that gap staging time frame.
Awesome. All right, we got one more person. He's got a few questions here. Bob Green. It's interesting, actually. A lot of the stuff sort of got fielded a little bit before we got to the questions, just in our conversation. But he's curious about your thoughts on the trade-offs for altitude versus incorporating some sort of active roll control for your sustainer.
Yeah, so I'd love to. I would really love to do it. But the biggest thing is just space and weight. And then on top of it is just testing it. If you were able to somehow squeeze one in, but in a 3-inch upper stage, like I don't see how you're going to do it,
Right.
Yeah. I mean, there's no like, there's no like, I guess like military equivalent, where like performance rocket that has like active guidance in like the 3-inch range that has the performance capabilities of like the upper stage of this rocket, right?
Right.
Like, yeah, the Stinger I think is like around 3 inches in diameter or something. But like, it's designed to hit targets like a kilometer away or something, right? It's not,
Right.
It's not designed, the motor's pretty small on it. So I don't think I'm going to I don't think I'm going to be able to fit in any kind of active guidance on such a small rocket. I'd really like to do it, at least for roll, there's nothing better than like a rocket that has like a nulled out, roll and like watching the ascent. And it's just so badass. Like, even if it doesn't fly that high, like what the stuff that Joe did with his little roll tab thing, was super cool. But realized like the thing that he had to give up was 1/2-inch thick fins. So like,
Right.
like if I increased the fins to 1/2-inch thick on my upper stage, it would go to 80,000 feet.
Right.
It wouldn't make it to 290,000 feet. So actually, like the fin thickness plays a very huge role. So it's incredibly important. It's why I build the fins out of carbon fibers, because you can get them so thin. So I don't see myself doing it. I'm also honestly just not that great at like electronics and programming and probably figuring out control algorithms and stuff like that.
Yeah,
that's not my forte.
Yeah, we get comments all the time, and people are like, you could get so much higher if you implemented this, and you can do, it's not that difficult to build this circuit. And I'm like, man, you're way out of my wheelhouse right now. 90% of my flights, I still twist wires together instead of having a switch, man. Like it's always comments on like the 12-inch rocket too. Like that thing's optimized for altitude.
So maybe I'm just not smart enough to do it. Right?
That's the
denominator. Yeah.
It's just an unbelievable extra step of complexity on. Well, I know you say that the rocket is pretty simple, and on its surface it is pretty simple, but there's already a decent amount of complexity there that you're kind of relying on everything falling into place. So
yeah,
adding
I couldn't imagine. Like, I think that's just like, that's just adding a massive layer to it is. I mean, yeah, there's no one thing in that rocket that is complex, but like the whole thing winds up being pretty complex.
Right.
You know, so yeah, I couldn't imagine doing it. Yeah. So
he continued. He asked. I had to reword the question a little bit. I actually asked him for clarification, but he asked specifically about nozzle design. But I would maybe ask entirely about the motor. But what was taken into consideration for your sustainer motor, given the like air density and where the motor was to be lighting? Did that have an effect on nozzle throw diameter or anything for the motor geometry?
So the trick with Mesos is just playing like the same trick that the Arcus plays. The longer that burn time, the more performance you're going to get, because you're just trying to minimize the drag on the rocket. And so like, you know, the slower you push it through the air, the less drag you get, you know, because like B squared on in the drag equation. So you want to just minimize the velocity, and then you want to maximize the altitude that peak velocity happens at. So with the geometry of the upper stage motor, like the only way I could think of to make a motor burn for a really long time was the moon burner. So that's why I picked that geometry. For the nozzle, I tried to expand it as much as I possibly could. So I did run it with a larger exit area than what I had been running up, you know, for it on the ground. And that really was just constrained by the rocket itself. The rocket's kind of small and it's only 3 inches in diameter. The nozzle's got to clear a few things, so I made it as big as I could, which I think wound up being like 2.15 inches for the exit area.
Dang.
So I just tried to make it as big as I could, and then that was the only trick I really played. There was no real math to it, I guess, other than the space constraints.
And then his final question, I kind of saved this one for last because, like I said, Taylor and I are sort of venturing into two-stage stuff, and it's something we're all leaning towards a little bit. And I feel like every rocket person has to want it just a little bit, right? So could you walk us through your experiences getting reliable second stage ignition and proper stage separation?
Yeah. So for stage separation, my rockets are always like the booster is a larger diameter than the upper stage. And that really helps like ensure that the inner stage is super stiff, because, you know, you get to sleeve into this larger diameter. So that's really helpful in keeping that section of the rocket stiff. But also it helps because, you know, when that booster motor burns out, the rocket naturally just wants to separate. So the booster's just got more drag because it's a bigger diameter, and the upper stage has got less because it's smaller, and the two just don't want to stay together. So, and honestly, letting nature kind of separate the rocket, it's going to pick the best time to separate it, and the most efficient time to separate it. So there is a separation charge on the rocket, but it's never had to be used. In some of the ground videos, you can actually see like the sustainer, it pops away, and then you can see the puff of smoke from the 2-gram charge that's supposed to separate them.
Interesting.
So yeah, I just let the rocket drag separate, and it always does. I've never had one not drag separate, except that like behemoth rocket I flew back in college, the 7.5 to 6 inch, that needed some help to push it apart. So that was that part. What was the rest of the question? I forgot.
Reliable second stage ignition.
Yes. You know, I've never had any issues with getting an upper stage motor to light because of the igniter. I've definitely had issues with like my avionics and setting like the criteria to stage or not to stage, especially like early on with like some of the early, like a lot of people flew like Altus Metrum type stuff, like around probably like 10 years ago. It was very popular before, Kate really became the Multitronics stuff kind of took over. So some of the logic with those flight computers was difficult. And so, I invariably set some setting incorrectly and it wouldn't light the motor. But for igniters, I've kind of lit motors every single way you can light them. I'll just tell you how I do it now. I've been lighting all my motors with copper thermite. So seems to just light the motor pretty much instantaneously, regardless of the altitude that you're at. So whether you're at sea level or 35,000 feet, it lights within less than 1/10 of a second. So yeah, that's what I've been using.
It's really good to hear. It's always hard in a public setting like a podcast to advocate for copper thermite because it is not a thing that you should just start playing with. But we used it in our clusters, and I have this great slow-mo video of all 6 of our outboard motors. You see the big white thermite flash, and then they all just instantly turn on together. And I was like, that is so good. It is the solution. It's just one that people shouldn't start messing with blind, but
it definitely takes care. It takes care to mix it. It takes time to kind of size the charges and to make them properly. But I wouldn't go and run thermite on my first big 2-stager if you've never run thermite before.
Right.
Like definitely stick to what you got and what you're used to. Don't try new things on these big flights. But yeah, if you got the time, like spend a year messing around with thermite and I guarantee you can figure it out. Yeah, it's great. It just works real good.
But does anybody have any final thoughts? We're at the end of the mailbag segment, so that's pretty much going to wrap us up.
I don't think so.
Well, Kip, thank you so much for being here. It was awesome to get to chat with you. I've been a big fan since you put out that video. I'm glad to know you're working on another one. Super excited to see that. It's
working on another one. Yes. Yeah, luckily YouTube doesn't pay for much of the rocket stuff, but they do throw me a few bills every month with that one video. Somehow just continues to capture people's views. So,
as someone who has spent hours and hours staring at Adobe Premiere, I can say from my perspective, it's just like so well done and meticulously edited, and just like it's the perfect package as far as covering the entire project end to end. So I'm glad that it got rewarded with the view count that it has thus far, because I can definitely see the effort that went into it.
Yeah. That was a decent amount of effort. I feel like this one I've been it's even harder to do a video about flights that don't go well than it is.
Right.
Like doing a video on a flight that goes well is pretty easy, It's like here it is. But doing one where you gotta have to do some like failure analysis and stuff definitely takes some time. I should probably switch to Adobe Premiere. I'm still using like Final Cut Pro, and it's not my favorite program.
It's pretty good though, and it doesn't cost $50 a month, so there is that. But
there is that. Yes. Yeah.
But again, thank you so much for being here. We are the Anti-Gravity Group. This is the Anti-Gravity Group podcast, joined today by Kip. Say it with us, friends. Daugirdas.
Yeah, there you go.
But thank you guys for being here. We will see you next time.
See ya.